Okay, good morning, good afternoon, everyone. Welcome to the second webinar about the value of water in Canada. My name is Roy Brouwer. I'm the Executive Director of the Water Institute and Professor in the Department of Economics at the University of Waterloo. And I'm joining you here today from Finland, where I'm visiting University of East Finland, very close to the Russian border, where the local time is 7 p.m. And because I'm here in Finland, I will skip the land acknowledgement today. Before I introduce today's speaker, just a few housekeeping items. During the talk, you can add your questions to the Q&A box, and you can do this at any time throughout the talk, and I will then help the speaker to get through those after the talk. And please use the chat box just for technical issues. The webinar will be recorded and posted to the website of Global Water Futures Project website and to the Water Institute's YouTube channel afterwards. So turning to the speaker of today, it's my pleasure to introduce Dr. Yi He. Dr. He is professor in the Department of Economics at the University of Sherbrooke in Quebec. She holds a PhD in development economics from the Centre d'études et de recherche en développement international, CERDI, at the Université d'Auvergne in France. And before joining the University of Sherbrooke, she worked for the World Bank and UNEP. Since 2005, she conducts non-market valuation research through a series of projects that study the economic value of ecological services, for example, in the St. Lawrence, Tremblay of Greater Montreal, and projects related to wetlands and public services provided by water treatment facilities around Lac Magog. She also uses methods that focus on public well-being using QALYs, that is quality-adjusted life years, and she zooms in on the social acceptance of mining projects in Quebec in her research. She's co-author of the methodological guidance of URANOS, that is the Innovation Consortium in Quebec on regional climatology and adaptation to climate change on the economic valuation of non-market goods. Professor He is also actively involved in projects evaluating environmental goods and services in China, where her research and collaborations are ongoing with several universities and on different environmental aspects, from the value of water quality improvements in the Pearl River, Panglong River, and Lake Dianchi, to air quality in cities like Nanjing, Jiangyin, Qingtai, and Guizhou. Dr. He, we're very happy that you agreed to participate in this webinar series on the value of water in Canada, and I'm happy to hand over the digital floor to you.
Thank you, Roy. Thank you for the invitation, and I'm very happy to be here today to share with you some of my research. And firstly, I need to share my screen. Roy, can I do that? No, I cannot. Can you just? We need to go outside. Yeah, great. Thank you. Okay, so let's start. Great. So thank you very much, and I'm very happy to be here today. And I will try to talk about the economic value of water quality in Quebec based on several studies that I did, and I will try also to give you some introductions about the water quality issues in Quebec, certainly. So as most of the people know, Quebec is rich in water resources with its millions of bodies of fresh water and the tens of thousands of rivers and the St. Lawrence. And Quebec has almost 22% of its territory covered by water. Although it's a very important resources, the very recent report, le rapport sur l'état des ressources en eau et des écosystèmes aquatiques du Québec, published in 2020, showed that the situation of water quality is not so satisfactory. Only half of the indicators are positive, particularly in link with the water quality of the St. Lawrence River. But we still have 20% indicators showing a deteriorated status, and another 33% only classified as intermediate. And in Quebec, the water governance is organized by on the watershed level. Here you have a map showing you the 40 organisms, the bassin versant, OBV. According to the issues that need to be prioritized, identified by the 40 OBV, we can find that in the first place is the bad quality of the water, and the second place, destruction and degradation of the quality of wetlands, which is also directly related to the water quality. And the OBV also mentioned that the main causes of such a water quality problem are the economic activities and anthropic pressures. If we take the bad water quality as a case presented by the blue bars, we can see that most of the OBV mentioned activity of agriculture, urbanization, and the shoreline erosions to be the main cause of the bad water quality. So why such situation? And my guess is that the economic value of the water is generally underestimated in the economic in Quebec economy. I have two examples, although that is not a very overall situation, but just the two elements for you to understand why such situation can happen. The first is actually our colleagues, Statistics Canada Institute of Statistics to Quebec. They have this every year they report the contribution of the in the GDP of the sectors using water. So according to their calculation in 2016. The water contribute only to 0.28% in the Quebec economy, which is about a little more than $1 billion. And by pure coincidence, in the same year with some colleagues, we calculated the annual economic value of the ecosystem services provided by the water of Lake Saint-Pierre, which is already $3 billion. And another example here is about the water pricing. And we know that Canada has the lowest water pricing in the world, which related to very high volume of consumptions by person. And the situation compared to the average situation in Canada, Quebec has even lower water price. And in 2010, we adopted this redevance exigible pour l'utilisation de l'eau. According to it, actually, all industries that withdraw a certain amount of water or more every day need to pay a fee of 0.25 cents to 7 cents per meter cube. Depending on the activities they have. And we have this very largely covered zero fee, covering domestic use, non-commercial use, and hydraulic energy generation and agriculture activities. And although the very low price in Quebec can be justified partially by its rich endowment, we still know that this notion should be discussed with care, because economic series of value mention the different dimensions of this concept. For example, we have the objective concepts. The value of the object is determined by the sum of the cost of the resources that went into its production, so its price, cost. But we also have the subjective concepts. Value of the object is determined by how much pleasures, satisfactions that we can get from using it. So here we'll talk about utility. But we also have another dimension, which is the importance, the appreciation or emotional value that we attach to goods and services, like when we view water landscapes, and we got this emotional spiritual experience, which can be very important for us. And although the excuse me, although the water price that we used in Quebec can be equalized to the objective to cover its production cost, But we know that its importance may be much more higher, especially since it's a supportive role of our everyday life. That mentions to us the very traditional, very classic discussion in the history of economy, the paradox of value. We know that the water is way more important for our everyday life, for our survival. But the diamond has a much higher price in the private markets. And we also believe that underestimation of the value of the water can be further exacerbated due to the fact that water is highly regulated goods, and there is no market to exchange it. And the water share this public goods natures, which make it very difficult to prevent free riding behaviors. So large amount of the water, large quantity of water can be withdrawn without compensation, and it's very difficult to prevent its overpollution. In environmental economics, and we have this total economic value notion, and this total economic value notion can be further distinguished into use value and non-use value. In use value, the direct use value include all the value related to the direct use of water. For example, water used as inputs in economic sectors and domestic use, non-consumptive use like recreation, navigation, cultural activities. But we also have the indirect use of water. For example, the indirect environmental services provided by water, waste assimilation, habitat and biodiversity protection, hydrological functions such as flood control. And we also have the option value. Option value is actually some kind of insurance premium that assure our future chance to use the water. Since it is this consumption actions is not happening now, some people prefer to regroup it with the non-use value. And there are two other more classical non-use value elements is the existence value, the intrinsic value of water and water ecosystem, including biodiversity. And a more concrete example is that sometimes the people can attach a value by knowing that a wild river continue to exist, even if they will never visit it because it's very far from where they live. And we have the bequest value, the value of the water related to ecosystem left and sustained for the benefits of future generations. So if we look at here, the first rectangles present somewhat similar to the economic benefits or returns, like the 0.28% of the GDP contributed by the sector using water, but we still have all the other elements where we try to capture the utility, well-being, importance of the water-related ecosystem services. Although we know that it's we can just be happy to use the economic benefits, but we know actually the importance of the water is far more beyond this, and it's very important for us to get a way to understand the whole bunch of the elements and to make sure that our decision about these very rare resources to be right for today and for tomorrow. And unfortunately, very often the four elements here are not directly observable from the existing markets. So it's very important to use economic value evaluation methods, which will allow us to capture some of them. So there are also policy orientations aligning into these directions. For example, the United Nations Water Development Report published in 2021, where they believe that it's very important to recognize, measure, and express water's worth, and to incorporate into the decision making. And according to the study stratégie québécoise de l'eau, published in 2018, our last governments. And we also believe that it's very important to assurer le droit de chacun d'accéder à une eau de la qualité et de la quantité suffisante pour satisfaire les besoins essentiels du peuple. Donc, so there are different methods that we can use to evaluate the value of the water, and because but certainly there are market-based methods where we can get the information from existing markets. But we are more interested today about the non-market methods, which will give us the chance to measure the subjective value of the water. Here we can find reviewed preference methods in which we use the behavior observed in the market of complementary goods to review the importance of water to people. For example, hedonic price, where we can use if the water in the bay has been improved, and the houses built in the adjacent area will find their price go up. Everything being equal, this increase in the real estate price can be considered as a revelation of the value of the water quality. In the travel cost methods, where we can find a situation where the quality of water improved in a river, it will encourage more fishing trips. And this additional, the satisfaction that fishers get from this additional trip can be used to measure the importance value, or the economic value of the water quality improvement. We also have, it is not always lucky that we can find the complementary goods markets. So sometimes we need to use the expressed or declared preference. So here the importance is to construct a hypothetical market in which we will ask the people to directly declare their willingness to pay for the improved scenario. So here we have the contingent evaluation and choice experiments methods. I'm sorry. Okay, donc we will start with our first example, which is based on the recreation benefit loss due to the climate change on the lake of Saint-Pierre. So it's here I can show you market-based methods and the travel cost methods together. So the first things about the market. Okay, the first thing that we can see here is where located Lac Saint-Pierre. Lac Saint-Pierre is a enlarged part of the St. Lawrence River, and it's quite important in Quebec because it's the largest freshwater floodplain in Quebec, and an area of a very large area, 500 kilometers. Over 40% of wetlands along the St. Lawrence River is located around the Lake Saint-Pierre, and it's a very important habitat for birds and fishes. And it's run some sites since 1998, and is a UNESCO Biosphere Reserve since 2000. But St. Lawrence River is under big pressures since the beginning because 75% of the Quebec population live in the large watersheds of this river, and 1.9 million people live in a direct tributary. The ecosystem of Lac Saint-Pierre is profoundly affected by the human activities. It has been so alarming that in 2012, the Ministry of Flora and Fauna and the Park has decided to set up this 5 years moratorium of the yellow perch, which has been extended until the end of this year. And other bad news, according to hydrological studies that has been conducted by the Wuhanos, we find that under the climate change, it's very possible that the Quebec will live this short and hot and dry scenarios, which means there will be lower and earlier floods. So severe lower water levels in the St. Lawrence River and especially in the Lake of St. Pierre with very high temperatures. That means actually a very big impact in terms of ecosystem services. And based on this scenario, we worked with our expert panels associated with these projects, consists of geographer, ecologists, biologists, environmental scientists, and we have been able to put up this scenario. Currently, the situation is here, which is described by different attributes of the ecosystem services and habitat of fish, habitat of birds, and water quality. Water quality here is actually the different kinds of possible use which are allowed, and the waterfront conditions and the status of UNESCO and the Ramsar sites, whether we can still keep that if the climate change affect us in a very extreme way. So after discussion, several rounds of discussion, we got this hypothetical future situation where if you compare this here and here, you can see that all the situations will be worse if there is no active interventions from the government or from the municipalities. So this scenario was presented as the central part of our exercises on the online survey that we conducted in 2015-2016. And we find actually we have been able to get a representative sample of the Quebec population over 18 years old. And here we find that you have 165 persons who have visited Lac Saint-Pierre in the last 12 months, which is 7% of the population, and with an average a number of 4.7 visits per year per person. And if well presented with this deteriorated scenario, the average reduction in the number of the visits is 2.69 times per year. So this database actually can be used by different methods. The first thing that we can do very direct approach is that in the market-based, we can use this data to make a market-based estimation because we have very detailed information about what and how much the people have expended during their last visit. We find that each visit cost $65 per person, and if we account 7% of Quebec population goes to lake each year, with the average number of the visit each year, so the total economic benefits associated with this touristic activities will be $175 million per year. And if we account that there will be about 2.7 visits less due to the climate change, we can expect the future economic benefit loss due to the reduction of the popularity of the lakes to the visitors will be $100 million. But this database is actually constructed initially for the travel cost methods. In the travel cost methods, actually, our objective is to estimate this demand curve for the visit of the Lake Saint-Pierre, because we believe that further you are leaving from the lake, much more money that you need to spend to go to the lake. So fewer frequent will be you on the lake. So there is a decreasing relationship between the cost of the travel cost and the number of visits that you will be on the lake. If we take the representative person of our data, we can know that actually this person will go 4.7 times by paying a cost of $64 per visit. So this this rectangle in light green, the B1 actually can be calculated. And this is the amount of payment that this person need to pay to get this visit done. And the A1 is actually the consumer surplus in microeconomics, all the excess value in the content in the travel cost method, which measures the net satisfactions that this person can get from his NI visit. So what happens if the water quality comes to be worse in the future? We believe that everything being equal, the demand curve will switch inside, which means for the same person with the same cost, the same travel cost, the number of visits NI prime will be smaller. So if here is the 4.7, here is the 204. So we know that there will be reduction of the economic benefits, and there also the reduction of the net satisfaction. So that is what we did. Our first step is to calculate the water, to calculate the demand curve, to estimate demand curve, and we find that as we expected, higher is the transport cost. Lower will be the number of the visit because it's a significant negative coefficient, and the lake quality. We know that after climate change, lake quality will be worse, and we find that this situation will also affect significantly the number of the visit as we expected, and we have been able to trace the demand curve. It is nonlinear because we use a nonlinear estimation, and so we still have the possibility to show you the loss of the economic benefits, the direct use value, which is about $100 million loss, and this area in yellow gives you the loss of the net satisfaction of the visitors. It's about $232 million per year. It's about 57% of the current excess value of the St. Lawrence River. So so the reduction of the water levels actually can cause a big loss in the net satisfaction of the lake for the visitors. And in this studies, actually, the water quality has contributed to the construction of the total economic value of the Lake Saint-Pierre, but we cannot isolate the value of the water quality. What we do in this wetland-related studies is to isolate the economic value of the water quality, and this study is actually financed by the Wuhanos and the Fonds Vert du Québec, in which actually we're interested to understand how the situation, actual situation of wetland is bad, and what we need to do to improve the situation. In Quebec, actually, more than 50% of the wetland has been disappeared since 1960s. Because there is always this constant demand for lands, for urbanization, for transportation, agricultural activities, and touristic projects. But now we are coming in a point that we understand it's a time to get better understanding of the value that we are losing with the disappearance of the wetland. So what we do here is actually to put up the stated preference methods through an online survey, which is conducted in 2013, and in which we got a representative sample of general population in Quebec, about 1,900 persons, and half of the questionnaire is the contingent evaluation, another half is choice experiment by a random distribution. And so here you have the maps showing you the location of our respondents, and they are very similar patterns between these two methods. On the stated preference methods, the central part is to construct the hypothetical scenario in which we aim to improve the wetlands until the level of 1960s. That means we want to go back to the situation of 1960s with very detailed measures listed in our questionnaire. And to make sure that we can make comparisons between our two methods, actually both methods are described, in both methods, the scenario are described by the attributes like biodiversity, flood protections, and water quality, climate change, climate regulation, sequestration of carbon, and annual cost, which is a provincial level tax that people need to pay. And actually, we use the highest level in the contingent evaluation, highest level of improvement in contingent evaluation studies. And then we use the various values to construct the choice experiments, choice sets. In the contingent evaluation studies, this is our scenario. So the state curves are detailed by the actual level of the ecosystem service quality, and the situation in the future can be understood by comparing these two columns. So we can see that, for example, for the water, actually the situation of many waters in Quebec is bad. Actually, the concentration of the CFCs is very high. Objective is to reduce that and to reduce the concentration of CFC to make sure that the water come back to the good quality, for example. And the people actually facing this contingent evaluation exercises need to decide whether to accept the scenario of improvement or to stay in the statical. When he stayed in statical, certainly there's no changes of the environmental related qualities, but they will need not to pay. But if they decided to come into the improvement scenario, they need to pay a certain amount of money, varying from $500 to $600 in exchange for the improved situation. So actually, we will be able, using the 900 responses that we observed by our survey, we have been able to calculate, to estimate the probability to accept the improved scenario and be able to calculate the willingness to pay for this scenario. As you can see, the value of the WTP is about $460 around. And another special details is that actually we have a follow-up question in which we ask the respondents who accepted to pay for the improvement scenario to distribute the amount of their willingness to pay to the four different attributes, so in percentage points. And this will give us a chance to look at the importance of water quality later on. And in another part, half of the questionnaire, we have the choice experiment exercises, in which actually the people will get 5 of these choice sets that I show you one as examples, and in which people will have like 2 products to choose, all don't spend his money and stay in the staticals. So here actually the different projects has been promised with the attributes improved until different levels, but accompanied by a payment. And if you don't want to get all this kind of project, you can stay in statical. That means the situation of wetland will be the same as today, but you don't need to pay. So here, actually, we want to put people in a hypothetical markets, like in the content evaluation methods. But in the content evaluation methods, we have only one product, but here we have more products. It's very close to your choice in a supermarket. You have different products on the shelf, and you will try to choose the product that's most interesting for you by paying the price that you are consent to pay. So we have the estimation results. As you can see, the probability for one project to be chosen is significantly affected by the attributes and also by the social demographic characteristic of people. And the way the spatiality of the choice experiment is that we will be able to calculate the willingness to pay for each unit of improvement for each of the environmental attributes. Taking the water quality, as you can see, Quebec people actually are willing to pay around $2 for 1 CFC reduction in the concentration, in its concentration in the water. So finally, if we want to compare the contingent evaluation with the choice experiments, we go back to our contingent evaluation scenario. From there, we have the total value of the willingness to pay and the percentage points of value that people have put into different attributes. Or we can also calculate the willingness to pay for this scenario based on the estimation results of the choice experiments. As you can see, these numbers are very similar. That means there is a very good stabilities, external validities of the different methods, internal validations of the same methods for the same group, for the methods of belonging to the same group of approach. But another thing that I'd like to draw your attention is that the water quality is actually taking the biggest share in the total WTP for the improvement of wetlands. As you can see, 30%, in average, 30% of the willingness to pay in the CV samples, and 46 to 50% in the choice experiment. And this is not the only studies that we find this tendency. A very interesting observations through the different studies that we conducted in Quebec is that the Quebec people always give the highest, I say higher here, actually in most of the case, highest willingness to pay for the improvement of the water quality than all the other ecosystem services. Since I still have time, and I can show you another studies that I conducted under the mining context. So in this studies, actually, we find that more and more people are making a protest because they don't want the new mining project. Since 2013, more and more people are concerned by the potential environmental, social, and economic consequence come to say that we don't need so much mining projects. So the Tribunal Administratif du Québec in 2014 said that we need to weigh the fact in function of what is acceptable, what is not acceptable in a mining projects in the society by ordinary citizens. So here, what we did is to conduct the choice experiment studies under the mining context. So here we present to people different kind of mining projects described by attributes, another one small. So since the mining projects will cause negative consequence to the environment, so very often in the practice, we promise the tax rebate for the citizens. So it's a willingness to accept approach. So what I would like to attire your attention here, because we have two elements related directly to the environment, the mining status, underground mine, open mine, and monitoring scheme of the water quality. Whether it's by the mining company itself, it's a very bad situation, by the government, all the monitoring can be done by the independent committees. And here, as is our distribution for the respondents, we have put a lot of efforts to make sure that the resources regions can be well represented in our database. And so here you have a choice set. So we have two different projects having very different environmental consequence and other project related communication mode and capital partnership, job creation, and the tax rebate. So here you have the estimation result, which is which cannot be directly interpreted because we use the effective coding to make sure that we can get the willingness to pay for each of the level that we are interested. So here you have the willingness to pay value, and we still have the environmental consequence at the top. As you can see, when we are in the status cost, we don't need the compensation, but when we go from a relatively mild environmental consequence to severe environmental consequence, the compensation will increase. The compensation here is measured by the decrease of the utility. So all of them are negative, but negative means something lost, something lost, so we need to compensate. And I want to just show you the water situation. And as you can see, if it's a mining company to take care of their monitoring, it's $1,600 like annual compensation. And if you compare the numbers between different attributes, once more you can see that the water issues is still the most important dimensions that influence people's choice. And so I still have time. There are other ways, maybe not this one. So the question is very unique situation in Quebec that people putting so much importance to the water quality. So here I make a very impartial comparison of the Quebec studies with studies conducted by our colleagues in other provinces. As you can see, according to different category of ecosystem services related to water quality, we can find that actually the situation of Quebec is very close to the situation in other provinces, either for the recreation activities or the wetlands, where we can make this kind of comparison. So Canadian population are putting also very big importance in the water quality while discussing the ecosystem related to water bodies. And this is not even only the Canadian situation. In the studies that I conducted for China, there are several ones about water qualities. As you can see, for this middle income country, we can call, although the Chinese doesn't so much agree, and we can see that Chinese people are also putting a lot of money to express. Chinese people also has a very high willingness to pay for the improvement of the water quality. So, try to give you a general picture about how can this value to be big. So here, since all our studies are representative scenarios in Quebec, representative population subsamples in Quebec, we will be able to extrapolate our value, which often reported in WTP per year per household to the scale of the province, total province. So here you can see that very often this improvement of water quality means very important improvement of a preference, and sometimes this value can be extremely big, even for some very local case. So Lac Magog is a small lake 5 minutes from my house. This is only direct use case for the household having access direct to the lake. $1.8 million per year for the 900 houses. So the value can be very big. So what can we do with these numbers? And we are excited to get numbers, but how can economic valuation play an important role in the water governance? My guess is that we can play an information role, because by collaborating with colleagues of other disciplines, we can understand what are the services affected and using economic model to estimate the value. And this information with statistics inference, and we will be able to provide a relatively robust information about the value of the water quality. And this information, once used by the institution, can motivate the good decisions, which will generate good actions and scenarios. And even more important, the methods of based on the survey actually provide a much better chance to ensure a more effective citizen participation in water governance. So the opinion of Mr. X, Madam Y can be better taken into account on the table of the negotiation for the water quality improvement strategies. So I think that I will finish here, and if you have any questions, I will be very happy to have your questions. Thank you very much.
Thank you, Yi. Thank you for an excellent overview. Thank you very much. So everyone who's participating, if you have a question for Dr. Hay, please enter the question in the Q&A box. There are currently none, so I'll ask some first questions myself, Yi, and give others the opportunity to enter their questions in the Q&A box. So you gave some really nice practical examples of applying non-market valuation research in Quebec. And then at the end, you showed how that could be integrated in actual policy and decision making. Do you have any experience with the uptake of these results in actual policy and decision making? Have these results been used?
Well, we have several small pieces, and it's very difficult because there are two elements that is very important. The first is the policymakers need to believe in your methodology, and Roy, you know that our methodologies, especially this based on the hypothetical scenarios, will always lead people to think, okay, maybe the respondents are exaggerating their preference, and at the same time, but sometimes the policy intention is there, and they will look at your number as a way to validate their initial guess. In that case, actually, these methods can be very useful. Sometimes when they are ready to go, and you give these positive signals, they will just take that and to be very happy to go forward. But in the case where our studies can be considered among all the other factors, and the methodology sometimes providing very high number, bigger is your number, bigger will be the suspicions. So that is the part of very difficult stories. And another example, not in the environmental issue, and we have another project to look at the society's preference from centre de justice de proximité. It's a project that we do evaluation of the pilot projects for the Ministry of Justice. And actually, when we have our first round of the results, before we got our final reports based on these numbers, and the people have got, the Ministry of Justice has decided to expand their practice, pilot practice to much more regions. So when we do our pilot, there are 3 centres de justice de proximité, which aims to help people with the simple justice issues, especially information, the role of information, giving correct information. But at the end now we have 8 centers in different cities. So that's another. It's a contingent evaluation methods that we use combined with the directly observed data, and I believe there is how to say, there is this volunteer. There is this vocation to go there in the government, but sometimes the timing can be very important. Mm-hmm. But we are not totally accepted by the Quebec government, not yet.
So that's why your first example, where you combine revealed and stable preference methods, what was very interesting, I thought, where you use the travel cost, and then you also have a stated preference study, and you. I don't remember exactly. I must have missed this. So you're $100 million per year as a result of climate change. This was recreational loss. That was based purely on the revealed preferences, or also on the stated preferences.
The 100 is not even revealed. It's actually the loss of the payments, because each payment you do in the during your visit is actually some kind of revenue for the economy. So here actually we have like $100 million less because people will visit less. So it's like the concrete money. Actually, the Ministry of Flora and Fauna and Park like very much these numbers. And then we just present how the satisfaction can go down. And these numbers, they have very well accepted too. But then when we still have, I don't present today, we have also the Fisher size survey to know how in the contingent evaluation choice experiments methods, and this part of the data, since they just explode, and they decided to put that away. But what we have been able to find in this study actually give a very good correspondence to what they are in mind, because actually what the Ministry of Environment wanted to do at that time is to buy the plan inondable flooding plan from the agriculture practitioners to make sure that we can make a better preserve of the water quality and the ecosystem services on the lake. And the number that we provide seems to justify these purchases. So.
Yeah, very good. So that sounds very promising. So there is in the meantime, we have a question from Pat Lloyd Smith. So he says, thank you very much for the talk, Yi. And he's asking you about the last example that you showed in the mining sector, I think, for the willingness to accept example. Can you explain a bit more what motivated you to use the willingness to accept framing? And were there any challenges you encountered during the survey design in ensuring that respondents found the payments credible?
Yeah, it's a very good question, Patrick. We have no choice, actually. The thing is that removing the mine is a very difficult measures. You know that sometimes the mine is closing, and it takes 100 years for the land to be recovered by nature. And we don't have a very explicit information about how the consequence on water quality can evolve in the time. So in this, in other things is since we have motivated our project by the social acceptability of the projects. So it looks to us that adopting future projects, mining projects, and making people to do the trade-off between different consequences and compensation seems to be the most natural way. So I know that there are a lot of discussion about the divergence between willing to pay and willing to accept, and we know that, and we still struggling. This paper we have not yet published yet, but although the student has finished his PhD, actually we're still struggling with the fact that since we use the willingness to pay, willing to accept, we explore the distance decay aspects in the paper, and our distance decay only minorly appears with the environmental consequence for the water and for the underground or open pit mine, but for all the other factors, they are not there. So we believe that using the willingness to accept can contribute to this situation, because people just, there is no budget constraint. We can ask no matter what the quantities, and that's why all the numbers are very big, and we know that, and we know there's some exaggerations. But what we are interested in is in this relative comparison between different attributes, and that has been used as a weight to calculate the social acceptability of a future mine projects.
Thank you very much for the answer, Ji. I don't see any more questions. We're 2 minutes to the hour. I then propose we stop the webinar here. I just want to take the opportunity once again. Thank you very much, Yi, for this excellent presentation, and also for your responses to the questions that we had. Thank you very, very much. This was very interesting to see how non-market valuation research was applied in Quebec. As I mentioned at the beginning, we are recording the talk, and you can find it in the coming weeks at the project website, the Global Water Futures Project website, called Valuing Canada's Water Resources and Aquatic Ecosystems. You can also find the recordings on the University of Waterloo's Water Institute YouTube channel. So stay tuned, it will be posted there in the coming weeks. And then we look forward to meet you again in a month's time on Wednesday, May 11, when we will have Professor Robin Gregory with us, who will talk about our understanding of the concept of value. And we're moving to the western part of the country. Robin works for the Institute for Resources and Environmental Sustainability at the University of British Columbia. So I look forward to meet and greet you again in a month's time. Stay well. Thank you once again very much, Yi, for your excellent presentation, and thank you all to the participants for attending this second webinar on the value of water in Canada. Thank you very much.
Thank you. Have a nice day. Bye.
Thank you. You too. Thank you. Bye-bye. Yi, do you